All right, so today we're going to continue our 2020 Math Paper 1 lecture. And like I said, in terms of mathematics, Paper 1 is a little bit challenging. So most of your marks in mathematics have to be targeted towards Paper 2. So after this paper, we're going to focus mostly on Paper 2 questions that I think you'll be able to solve. We're going to do at least 4 of those topics. But when it comes to Paper 1, answer as much as you possible well in terms of the things that you fully understand and know. Do your best in paper 1, and then do your very utmost best in paper 2. Make sure you choose what you're going to answer in paper 2. Otherwise, paper 1, it's answer all questions. It's a little bit tricky. So let's start with this question here. Question 6. Can you see question 6?
Yes.
All right. It says use set notation to describe the shaded region in the diagram below. So when we're talking about set notation, every time you see this word set notation, we're talking about things like A intersection B, union C. This is set notation. So they want you to figure out what this set is in terms of set notation. Is it R intersection Q? Is it P intersection Q complement? That's what they want. So every time I look at such a question, the first thing that you are supposed to do, because most teachers are going to tell you no, start shading like this, and then you start shading like that. For me, this method doesn't work and it just confuses me. So I'm going to show you an easier method to handle this question. So the first thing that you can do is, in each space of all these sets, just indicate one element. So you indicate 1 there, 2 there, 3 there, 4, 5, and 6. So you've seen that I've indicated one element in each of the spaces in this Venn diagram. Then the next thing that you're going to do is, because math, things have to make sense. You have to define your sets. So the first set that I can describe here is set P, which is now 1, 2, and 4. We can define set Q. Set Q is 2, 3, and 5, this set here. And then we can define set R, which is 4, 5, and 6. So now here we want to define this region here where the 5 is. So you've seen where the 5 is. That's the region that we're trying to define. So remember, this is worth 2 marks. So you're trying to get as much marks as you can, whether it's 1 mark or half a mark, all marks count. So you tell the examiner that, all right, this region here, 5, it lies between two sets, right? It lies between set Q and set R. You can see set Q has 5 and set R has a 5, meaning it's lying in between an intersection. So the first thing that you tell them is Q intersection R will be an intersection set is the things that they have in common. So between Q and R, there is, I didn't add an element here, right? So 1, 2, 3, 4, 5, 6. Let's add 6 there. And let's add 7 there. All right, so meaning set Q becomes 2, 3, 5, 6, 2, 3, 5, 2, 3, 5, and 6. And then set R becomes 4, 5, 6, 7. So 4, 5, 6, 7, 4, 5, 6, and 7. All right. So we do notice that this region here, this 5 that we've shaded, lies between set R and set Q. So meaning it's in between these two sets. So meaning it's an intersection. An intersection is what they have in common. So what is Q intersection R? We have got 5 there, we have got 5 there, we've got 6 there, and we've got 6 there. So you tell the examiner that, all right, I understand that that shaded region lies between these two intersection sets, Q intersection R, which is 5, comma 6. The examiner will be like, all right, this student has done something, so I'm going to give them 1 mark for showing that the region here we're trying to find this 5 lies between an intersection of set Q and set R. Then now you tell the examiner that, all right, I'm trying to get rid of this 6 here. I'm trying to get rid of this 6 here. Which set, so even set P will have 1, 2, 4, and 6. 1, 2, 4, and 6. So I'm trying to get rid of this 6 here. So which set can I use? I'm going to use set P because set P has that 6 there. So somehow set P is going to have the ability to get rid of that 6 somehow. So what are we going to do? We're going to get set P, but not only set P, we're going to get P complement, the complement of that set, because we're trying to get rid of this 6 by singling out this 5. So I cannot say set P as 1, 2, 4, 6, but I'm going to say P complement. So what is P complement? A complement means you get the set and you list elements that are outside this set. So set P is 1, 2, 4, 6. 1, 2, 4, 6. Meaning P complement will be 7, 5, and 3. So a complement is everything outside that set. So set P is 1, 2, 4, 6. Then P complement is 7, 5, 3. So P complement, we're going to say it's, let's put it in order, 3, 5, 7. 3, 5, 7. So you see now that set P complement can get rid of this 6 by singling out this 5. So how do we do that? We intersect these two sets. How are we going to do that? We'll say Q intersection R, close brackets, intersection P complement. So this is Q intersection R and this is P complement. What do they have in common? There's a 5 there, there's a 5 there. So our set will become 5. So this shaded region here that they want this is the answer. That's the notation. The answer will be Q intersection R, close brackets, intersection P complement. So you get your other mark for showing this set. So that would be 2 marks in total. So how did we solve this question? Let me explain again so that when you are revising this, you should have this information in order. Step 1, we said in all these 2 spaces, just put 1 element. We added a 1 there, we added a 2 there, we added a 3, we added a 4 there, we added a 5, we added a 6, and we added a 7. Then you tell the examiner that, all right, this is the shaded region here where the 5 is. You tell the examiner that this 5 lies between these two sets. There is set Q there and there is set R there. So it's an intersection. So you tell the examiner this part. Q intersection R is equal to 5, 6. Then you tell the examiner, all right, I want to get rid of this 6 here so that 5 should remain alone. How should I do that? I'm going to intersect it with set P, but not set P, P complement. because we can single out this 5 there. So what is P complement? We get set P 1, 2, 4, 6. That's set P. Then P complement will be everything outside set P, which is 3, 5, 7. So P complement is 3, 5, 7. Now that we have this set P complement, we can intersect it with set Q intersection R to get rid of the 6. So what is Q intersection R intersection P complement? There's a 5 there, there's a 5 there, which is 5. And that's the shaded region that the examiner wants. Meaning the answer will be Q intersection R, close brackets, intersection P complement. So this is math paper 1. You just have to ni kukosa. You really just, there's nothing complicated here, but you just have to be able to understand the set terminology. What's an intersection set? What's a complement set? What's a union set? What's a subset? This topic in terms of sets, once you understand the terminology, once you know what an intersection is, what a complement is, the only thing that you have to do is just logically find the answer. So make sure, I'm going to send you this video after my class at 17, somewhere there. Make sure you solve these problems today. When I send you this video, get a piece of paper, try to figure it out, watch the video, solve it even 5 times if you must, until you understand the method that I've used to find this answer. Will you be able to do that?
Yes.
All right. It's not hard. Just tell yourself, tell your brain that I am good at math. If you start telling your brain that me, I'm bad at math, your brain is going to say, yeah, it's probably true, I'm bad at math. So just tell yourself that, I can solve this, I'm good at math. And I'll use this video to understand how we were able to solve this question. Okay, so these are matrices. And matrices, what the examiner wants you to know is, do you know how to add matrices? Do you know how to multiply matrices? Do you know how to find the inverse of a matrix? Do you know how to transpose a matrix? And do you know how to find the determinant of a matrix? So these are the 5 things that the examiner is going to target. And this question, it looks like they've targeted the transpose question and multiplication of matrices. So all you have to do is just follow the steps that I'm going to show you right about now. So a matrix is, let me give you an example of a matrix. We can have A, B, C, D. That's a matrix. How do you know the order of a matrix? No. The order of a matrix. The order of the matrix is row and columns, row times column. So we're going to say row multiplied by column, row multiplied by column. So this line here, that's horizontal. This is a row, and this row has got two elements in this matrix. So sorry, it has got one row. So that's one row multiplied by how many columns? There's one column there, the vertical one, and another column there, another vertical. So this is a one. Oh, sorry, this is another row also. So it's a 2 by 2 matrix. Yeah, it's a 2 by 2 matrix. So one row, that's 2. One column, that's 2. So this is a 2 by 2 matrix. So a matrix, how do you know the order? It's row multiplied by column. And just knowing this rule, that a matrix has rows and it has columns. You can solve almost all questions in matrices. For example, this same matrix here, let me write it again, the 2 by 2 matrix, A, B, C, and D. So this matrix, we'll call it matrix X. A, B, C, and D, we can transpose this matrix. To transpose this matrix, X transpose, this row here will become a column. So this row, we're going to say A, B. This row here is also going to become a column, which will be C and D. That's how you transpose a matrix. You just convert the rows into columns. That's it. So that's what this question here is asking us to do. They are saying transpose this matrix C. So if you want to transpose the matrix C, which is 7, 6, negative 1, 0, we're going to get these two rows and we're going to convert them into columns, meaning C transpose will be 7, 6, negative 1, 0. So that's how we transpose the matrix. We just get the rows and turn them into columns. If you want to do the reverse, you can get the columns and turn them into rows. You're going to go back to the original matrix. Oh, wait, hold on. Okay. 7, all right, okay, 7, negative 1, 6, and 0. Okay, so that's how you transpose a matrix. Just get the column itself, transpose it into a row, get this column also and transpose it into a row. So that's how you transpose a matrix. So this is how we answer this question here. So C transpose would be 7, negative 1, 6, and 0. So let's move on to the other one, which is a little bit more complex, but you can solve it in a stepwise manner. Let's show the stepwise manner. So all you have to do here is read. So a matrix can be multiplied by another matrix, and a matrix can also be multiplied by a scalar. So for example, if I have a matrix X, we say matrix X is A, B, C, and D. This matrix X can be multiplied by a scalar, maybe 3. So maybe they can say, what is 3x? This 3 is going to multiply all these elements in this matrix X. So it would be 3A, 3B, 3C, 3D. So that's how you multiply a matrix by a scalar. All these elements are going to be multiplied by that scalar factor over there. But you can also multiply a matrix with another matrix. How do you do that? So let's write another matrix here. Let's say matrix K. Matrix K, we maybe name it W, X, Y, and Z. So when multiplying matrices, you just have to follow the sequence. Again, row will multiply by column. So this entire uh, row is going to multiply this entire column. How are we going to do that? We're going to say A times W. So XK will be A times W plus B times Y. So plus B times Y, you leave a space. This entire row is going to multiply this entire column. We're going to say leave a space, space, A times W plus B times Z. Then again, this entire row is going to multiply this entire column. We're going to say C times W plus D times Y. D times Y, you leave a space. This entire row here will multiply this entire column. So leave a space, C times X plus D times Z. And then your answer, you're going to get your answer after doing some algebraic manipulation. So using this same method, let's find the value of X. How do we find the value of X? We first try to read and understand the question. Let me put the question for you in matrix notation. So we're going to write the question here. We're trying to find the value of X. So since we're trying to find the value of X, the first thing that we're supposed to do is put the entire question in matrix notation. The question says if you have matrix A multiplied by matrix B, it has to give us matrix C. So let's write this. Matrix A is this one, which is 2, 3, 1, and 0. Matrix B is negative 1, 0, x, and 2 will be equivalent to, will be equal to matrix C, which is 7, 6, -1, 0. Just by arranging things like this, the examiner will probably give you half a mark. Because like I said in math, you have to give the examiner a reason to give you marks because they know that, all right, many students face difficulties in mathematics. So what can we do to maximize the efficiency of marking this student? Does this student understand the question? Does this student know how to read? Maybe they just made a mistake in terms of multiplying. So where can I give them marks? So where to get marks, you have to show the examiner that you understand the meaning of this. If I multiply matrix A with matrix B, I'm going to get matrix C. So we continue. This entire row here is going to multiply this entire column. So let's do that. We said 2 times -1. So we're going to have 2 times -1 plus 3 times x. So 3 times x. You leave a space. After leaving a space, you say this entire row again will multiply this entire column. You say 2 times 0, 2 times 0 plus 2 times 3 times 2, sorry. 3 times 2. Remember, you need to be part of a huge matrix. Then this entire row will multiply this entire column. So this will be 1 times -1. So 1 times -1 plus 0 times x, 0 times x. Then 1 times 0, 1 times 0 plus 0 times 2, 0 times 2, like so. So all we have to do is now evaluate. 2 times -1, it will be -2. 3 times x, it will be 3x. So combining these two, -2 plus 3x, we cannot add these. So our matrix will be -2 plus 3x. Then if we evaluate this here, 1 times -1, it will be -1. 0 times x, it will be 0. So it will be just 0 plus -1, which will just be -1. Then this side, we're saying 2 times 0, which is 0. 3 times 2, it's 6. 6 plus 0, it's just 6. Then this side, 1 times 0, 0, 0 times 2, 0, 0 plus 0, 0. So that's the matrix A times B. It should be equal to matrix C, which is 7, 6, I'm all right. -1, 0. So now we start corresponding elements. This element here, -2 plus 3x, corresponds to 7. This element here, 6, corresponds to 6. This element here, -1, corresponds to -1. And this element here, 0, corresponds to 0. We're interested in the ones that are in blue because we're saying this matrix here is exactly the same as this one. You can see there's a 6 there, there's a 6, there's a 0, there's a 0, there's a -1, there's a -1. Meaning this part here also, -2 plus 3x should be equal to 7. So that's what we're going to use to find the value of x. So we're just going to say, therefore, in math, therefore is a triangle like this with 3 dots. Therefore, -2 plus 3x is equal to 7. Then all you have to do is just solve this equation. We'll say 3x, the -2 crosses the equal sign to become an addition sign. 3x is 7 plus 2. 3x will be equal to 7, 8, 9. That would be 9. We divide both sides by 3. That cancels. X will be equivalent to 3, 6, 9. X is equal to 3. And that's our answer. Fabi, are you still with me? Hello?
Yes.
Sorry. I was supposed to teach you matrices properly, step by step, but we started our tuitions late. So you just have to be brave. I'm sorry. You just have to you have to rewind this video. Don't freeze. Don't tell your brain that you're not going to do it, but you can do it. Let me just repeat this whole procedure so that when you get this video, you can solve it step by step once more. Let me do this. Where's my marker? Where's my cursor? Oh, okay. There it is. It always gets lost during these lectures. So step 1, I told you we're trying to solve this. So I told you that a matrix can multiply by another matrix. So here the equation says, find the value of x for which matrix A multiplied by matrix B is exactly identical to matrix C. So we wrote the equation here. We said matrix A is 2, 3, 1, 0. Matrix B is -1, 0, x2. The product of these two matrices, once we multiply them, has to be exactly identical as matrix C, which is 7, 6, -1, 0. So I did say that when you're multiplying matrices, this entire row is going to multiply by this entire column there. So that's what we did. And again, this entire row will multiply with this entire column. So we're going to say 2 multiplied by -1 plus 3 multiplied by x, which is what we have here. 2 multiplied by -1 plus 3 multiplied by x. You leave a space. This entire row will multiply by this entire column. 2 multiplied by 0 plus 3 multiplied by 2. You go to the next row, you go to the next row. This entire row will multiply by this entire column. 1 multiplied by -1 plus 0 multiplied by x, which is what we have here. 1 multiplied by -1 plus 0 multiplied by x. You go to the other row, leave a space, 1 multiplied by 0 plus 0 multiplied by 2, which we have here. Evaluating it, if we say 2 multiplied by -1, it will be -2. 3 multiplied by x, it will be 3x. If I'm adding -2 plus 3x, this is an algebraic equation. I don't know the answer. I can't find the answer here because I don't know the value of x. So I'll just put it as one unit here, -2 plus 3x, which we have here. But the rest don't have algebraic variables, so we can evaluate them. 0 multiplied by x, any number multiplied by 0 is 0. 1 multiplied by -1, it's -1. -1 plus 0, it's -1. 2 multiplied by 0, it's 0. Plus 3 multiplied by 2, it's 6. 6 plus 0, it's 6, which we have there. 1 multiplied by 0, it's 0. 0 multiplied by 2, it's 0. 0 plus 0 is 0, which we have here. So this matrix here is the product, and it's exactly identical as matrix C, which is 7, 6, -1, 0. So these elements have to correspond. This 6 corresponds to that 6. This 0 corresponds to this 0. This -1 corresponds to this -1. Meaning this algebraic equation here, -2 plus 3x, has to correspond to this element 7. So because of this, we can make an algebraic equation. How do we do that? We say -2 plus 3x is equal to 7. Next step is just to collect like terms because we're trying to make x the subject of the formula. So we'll say 3x, this -2 crosses the equal sign, it becomes a multiplication symbol. We'll be left with 3x is equal to 7 plus 2. We'll be left with 3x is equal to 9, 7, 8, 9. We're trying to make x the subject, so we divide both sides by 3. The 3 will cancel. 9 divided by 3, our answer will be 3, 3, 6, 9. Therefore, the value of x is 3. You just have to practice this, then everything is going to become easy. Just practice and understand. Watch this video 99 times if you may. Okay, so question 8 is sequences. For sequences, I'm not so sure. I don't think paper 1 they give you formulas. No, I think they do. I am sure they do. But a sequence can either be an addition sequence, which we call an arithmetic progression, where the common difference is obtained by adding the previous sequence. Are we adding the previous sequence? Okay. Now we multiplying, all right. Or it can be a geometric progression where the next sequence is obtained by dividing the previous sequence. So it's either an arithmetic progression or a geometric progression. I hope I haven't swapped the two, but I don't think I have. We have an arithmetic progression and geometric progression. The only thing that you have to know are the formulas. Once you know the formulas, this question is extremely simple. Just one formula, and substituting in that formula, you are done with the question. So let's read the question and see how we can solve this. We have given that the 11th term of an arithmetic progression is 43 and that the first term is 3. Find, the first thing that we're supposed to find is the common difference. So how we're going to answer question 1 is we're going to use one formula, which is the formula for the nth term of any sequence. The nth term is just any integer of that sequence. So there is a formula. So step one, you would state the formula. If the formula has been given to you, just grab it. But the nth term is A denotes the first term. So A denotes the first term plus n minus 1. So this n is the exact number. If the 11th term is 43, so if they want you to find the 11th term, you put 11th term. If they want you to find the 10th term, you put the 10th term. So n is the position, the 11th term, the 12th term, etc. No wonder there's an nth there, the term. Then D is the common difference. The common difference is what you are adding to continue the sequence. That's the common difference. So maybe a simple, no, right here, yes. So this is the exact same formula. So from this information, we can extract the given information that they want. So how do we do that? The 11th term, so this part here, 11th term, n is automatically equal to 11. So the 11th term, I told you this n can be the exact term, it can be the first term, second term, 10th term, whatever it is that the examiner says. And the examiner is telling us that the 11th term here is 11 of an arithmetic progression as stated by the formula of the nth term. So the 11th term is 43. So Tn will be 43 here. So whatever we solve here, the answer has to be 43. And what do we want to find? The common difference. So now the only thing that we have to do is substitute into this formula. How do we do that? How do we substitute into this formula? We have the variables there. So where there is a Tn, we're going to add 43. Where there is the first term here, the first term has been given, so A is the first term, so A is 3. So in that formula, the first term is 3. So where there is A, we're going to plug in 3 plus open brackets, n is 11, so we're going to say 11 minus 1, close brackets. And what do we want to find? The common difference. This whole thing becomes an algebraic equation. And now how do we solve an algebraic equation? We expand and collect like terms, make D the subject. So this would be 3 plus, this would be 11 minus 1, it would be 10 multiplied by D. 43 is equivalent to 3 plus 10d. Now I'm expanding. 10 multiplied by d to be 10d. We collect like terms here. So collect like terms. Collect like terms here. So how do we collect like terms? That crosses over. We're going to be left with 43 minus 3 is equivalent to 10d. This will be 40 equivalent to 10d. We divide both sides by 10. Therefore, the common difference of this sequence will be 4. So the common difference is 4. You get your 2 marks. Oh, you get your 2 marks. How did we get our 2 marks? One formula here. What's that formula? Nth term is equal to the first term A multiplied by n, which is the term that you want, the 12th term, etc., minus 1 multiplied by d, which is the common difference. You extract the information. N is the 11th term, and that 11th term is equivalent to 43, so Tn is 43. You want to find the common difference. and you know what the first term is. The first term is 3. So you just substitute. Where there is Tn, you plug in 43. Where there is A, that's the first term, you plug in 3. Plus, where there is N, it's the 11th term, you plug in 11 minus 1, close brackets, uh, common difference. So what do you want to find? You want to find the common difference. So you solve it like an algebraic equation. 43 will be equal to 3 plus 11 minus 1, it's 10, multiplied by d to be 10d. The 3 crosses the equal sign, it becomes a subtraction symbol. 43 minus 3 to be 40. You divide both sides by 10. The common difference you're going to get will be 4. So we now know 4, meaning our equation will become nth term is equal to a plus n minus 1 multiplied by the common difference, and we will still maintain the same equation because now we know everything. So let me just put here where there is d question mark, we're going to put 4. So let's now find the fourth term. Let's find the fourth term using this same equation. Now that we know everything, we know the first term and the common difference, we can find any term in the sequence given the nth term. So they want us to find the fourth term. Since they want us to find the fourth term, things change now. The only things that will change here is the value of n and this final answer here. So what do they want us to find? The fourth term there. They want us to find the fourth term. The fourth term we do not know, meaning n is equal to 4, and the common difference is equal to 4. So they want us to find the fourth term. T4 is equal to, the first term will be 3 plus n now is 4 because the question says find the fourth term. We'll say 4 minus 1, close brackets. What's the common difference? 4. We found the common difference as 4. Meaning the fourth term will be 3 plus, open brackets, this will be, what's this? This will be 3 multiplied by 4. Then we expand, this will be, is it 4 times 3, that would be 12. So this will be 3 plus 12. Therefore, the fourth term will be 3 plus 12, so plus 3. The fourth term is 15. So that's how we solve these questions. That's how we calculate the common difference. It's not that hard. It's literally not that hard. Okay. Are we together? Hello?
Yes.
All right, so I have loaded you with quite a lot of information. So let me immediately send this video, then I attend my class. When I send the video, I want you to review it immediately and solve these questions using a paper, even 3 times or 2 times, so that you don't get lost. Do it immediately. Have a 1 hour study break immediately after I send you this video. I'm sure it will reach by 17:10, somewhere there. All right, let me end this lecture and send the video right away. I'll see you tomorrow. Tomorrow is Thursday.
Yes. For chemistry.
All right, I'll see you tomorrow for chemistry.